Good afternoon, everyone. My name is Miloš Švaňa. I am a doctoral student at the Technical University of Ostrava in the Czech Republic, quite close to Poland, actually. And my today's topic is extending Word2Vec with domain-specific labels, which will be interesting to present after we heard about transformers, which are, of course, as the previous presenter said, state of the art, but I still think that Word2Vec is still relevant for certain tasks. So if we could move to the next slide, please. And you can move, I think, 3 forward, so you don't have to click that much. Okay, thank you. The basic idea of Word2Vec and other embedding methods is that we want to represent tokens such as words using dense vectors. And ideally, we would like to have these vectors to be similar if they represent similar words. Similar in terms of quote-unquote meaning. One of the biggest advantages of Word2Vec when it came out was that it was, in a sense, able to capture, again, quote-unquote meaning of certain words. And of course, how we define similarity in case of Word2Vec and other embeddings is that similar words should occur in similar context. So they should be surrounded by similar other words when used in text. Okay. There is a message on the TV, but behind it, I just had a text that was saying that one of the basic approaches to create like a Word2Vec model is to train a very simple neural network that only has one hidden layer, and we can do this in one of 2 ways. We can either take the context words that surround our target word in a given document, and then try to predict this target word. These are usually one-hot encoded for the target word, and the context can be, for example, encoded using multi-hot encoding. So we have a vector of ones on a position that represent the target words. So this is one of the possible approaches. The second one is that we use skipgram, which is the other way around. So we use the target word to predict the context. The second one being more popular. Again, can you move to the next slide? It seems presenter. Yeah. So one of the biggest disadvantages of Word2Vec and similar algorithms is that it's not that great at discovering antonyms. So in many cases, words like good and bad are represented by similar vectors in this embedding vector space. And the reason for that is that these words, antonyms, can quite often occur in similar contexts. So they are used in a very similar way. So it's hard to distinguish between them. The idea that I came with, it's actually quite simple. I took the basic skipgram model, and instead of predicting the context words only, I also added some sort of a document label to the prediction. If you look at the objective function then that I was actually trying to optimize for, the first part in the parentheses is the standard Word2Vec skipgram objective function. We simply want to maximize the average log probability of predicting the right context given a certain word WT. And what I added to that is basically predicting also a log probability of maximizing the log probability of some document label given the same target word WT. And you can also see there is this parameter U, which is basically an integer weight that that lets the user kind of express the importance of the document label versus the importance of the context of the surrounding word. Using this very simple extension, I ran an experiment on a data set of tweets mined from Twitter API that were associated with this $, Twitter called this cache tags, and they are used to basically mark tweets that are related to some publicly traded company or an financial asset. So in this case, this $this is a symbol for the Walt Disney Company. So I mined a data set of 45,000 tweets about this company, which in total contained around 400,000 words. And as I mentioned, we want to predict some sort of a document label. And given that this work was done in context of my dissertation, which is focused mainly on portfolio optimization, investment portfolio optimization, and predicting financial risk, and so on, all this good stuff that is related to portfolio optimization, the label I chose was price change. If a tweet was published and its publication basically was followed by a price increase of that given stock, in this case it was Walt Disney, then it was labeled with a 1. And if, of course, the price went down, then the label was 0. So very simple labeling. And here is a short summary of results. I'm just showing here 5 pairs of words that could be considered antonyms, mainly in this finance space. In the paper, the table is a bit bigger, but just so the font here is not small, I just chose basically first 5 records from the table I had in paper. And the numbers that I show here are basically the cosine similarity between the embeddings of these 2 words. So, for example, the very first number, 0.772, is the cosine distance between the words buying and selling. Now, I compared or started the comparison with creating embeddings using a very well-known model, mainly for those who work with Python, called GenSim or GenSim, and their implementation of word2vec. And the first column, the GenSim column, shows the cosine similarity of the embeddings between the 2 words with GenSim. Then I took my model and tried using different values of U of that weight that describes the importance of the document label. And what we can basically see is that as the U grows, the cosine similarity goes down, with the only exception being the last row in the table, ahead and delayed. This is the only case where the cosine similarity actually increased a bit. But otherwise, in all other cases, the cosine similarity went down for U equals 10. As you can see, for U equals 1, the numbers are very, very similar to the GenSim model. It's a bit just a bit lower in some cases. And when we went to U equals 100, then the similarity is basically 0. So we could say that the words are almost orthogonal, or they're vectors. I also ran a second experiment, or looked at the resulting data from a different point of view. I took 75 words that were the top words associated with the positive label 1, so with the price growth. This was done very simply. I just took the number of occurrences of that word in positive tweets labeled 1 and the negative tweets labeled 0, and subtracted these 2 numbers. And then if the words were negative, I also basically adjusted for the proportionality of positive versus negative tweets in the data set. But here we can see that, for example, some of the words included the top 75 positive words were higher, nice, streaming, up, quite surprisingly, Netflix in context of Disney, while they're basically competitors. The mention of Netflix actually was more correlated with a price increase. And then for the negative words, there were words like down, coronavirus, below, downgraded, risk. These are pretty obvious. So what I did was I again created a pairs of words, but in this case it was a bit more arbitrary. I didn't look for like specific antonyms. I simply took the most negative word and paired it with the most positive word. Then the second most negative word with the second most positive word, and so on. So this is how I created like 75 pairs of most positive and most negative words. And again, I ran the same analysis. So I looked into the cosine distances between the embeddings of these words that were paired together. And again, we see that if the u is equal to 1, the average or the mean cosine similarity is about 0.36. But as the u grows, again, at the value 10, it gets to 0.31, and at value 100, it gets, again, almost to or quite close to 0. So what's next in this research? As I mentioned, my main focus is on financial risk analysis and portfolio optimization. So from my perspective, the idea is to use this model, this extension in this field, to apply it in risk prediction, maybe in price prediction, and in portfolio optimization. Which is related to 2 points, I would say. The fact that we still need to tweak the performance of the implementation so it can manage larger data sets, which again is the second point here, that we need to verify the method on a larger data set. And then the two last points, I'll just mention both of these were basically suggested by the reviewers of my paper, which I'm very thankful for. So one of the suggestions was to look into investigating how different lags improve the performance of the model. So what would happen if I would predict the price change not on the next day, but say in the next week or next month? How would that influence the performance of the model? And finally, kind of going back to the previous talk, I would like to see how this method, this simple extension that I propose, does in comparison with state-of-the-art transformer models such as BERT. Oh, I'm going back. Yeah, so this is the conclusion, just in one short statement. The paper that I present seems to suggest that document labels can indeed help with distinguishing between antonyms, at least in certain specific contexts. So that's all from me. Thank you for attention, and I'm ready for your comments and questions.
Hi, nice talk. Actually, I look at your formula. Actually, you target is one is the context, one is the document label, right? Mm-hmm. Okay, so my question is for the document label. Because I saw your data size, you use tweets is 45,000, and your word is 410,000. Yeah. So how about document label? You do some of the unsupervised clustering first on the document label, or you just that one you didn't mention, so I'm not so clear. Yeah. Document label. Yeah.
About the document label. Yeah. So I basically used. I didn't use clustering. What I used was financial data from financial portals such as Yahoo Finance to label the document. I was able to see if basically the publication of the tweet led, or if in the same day as the tweet was published, if the price of the company went up or down. So that's how I labeled the documents.
Okay, so roughly how many document labels you follow? Yeah.
Yeah, how many?
Yeah.
Yeah, basically it was a bit shifted towards the positive side. So there was a bit more documents that were related to price growth than to price decrease. I don't have the exact numbers yet, but yeah.
Because I saw your formula, you use that one for document label. Yeah. And I just share with you, actually, if you use link pack, Because personally, I use that one for competition. It just use Linpack, the Archibald, the clustering. They can automatically generate the document labels for you. So my second question is, you mentioned about the buying, sharing, upgrade, lower risk, the lower strength, something. Then you mentioned actually for the ahead and the delayed. That one we didn't see much difference. So do you think what's the reason for this pair? Yeah.
Yeah, this is something I have to investigate a bit further. I have some ideas. Either it might be caused by some randomness that I felt to maybe eliminate during the experiment. So there was maybe some randomness in training. That's one idea, and then the other that I briefly considered, but it doesn't really make sense, is that the difference in implementation between GenSim and my model could cause this difference.
Because I just refer to his paper, he's doing the temporal, right? It's based on the timestamp. Maybe ahead and delayed, maybe related to the
actually,
maybe interesting.
When I heard the talk of my colleague, I found this idea really interesting, using especially in this context of finance, because you have like a fiscal year. Things develop differently depending on what part of the year are we. So considering temporal information is actually quite a nice idea I might consider. So
yeah. In case because of finance, finance actually is
exactly.
Maybe your past history data might be enough, so you're just like Ukraine, right? Suddenly the war, then the stock market just boom. Something like this. Okay. So I think last one is, you didn't really compare with sport, because in the future you are going to compare with sport, and you use mean cosine distance. Okay, that's all. Yeah, thank you.
Thank you.
First question. I didn't ask questions before. You showed that there was one of the tables with the results with like u equal to 1, u equal to 10, and u equal to 100. And you commented that with u equal to 100, generally similarities drop down.
Yes.
But, okay, you showed it for some examples of antonyms, but doesn't it happen in general with arbitrary pair of words? If you increase u, everything will drop down step by step?
That's actually an interesting question to explore. I would say, quite based on my intuition, I would need to verify this by further experiments. But I would say that words that are related to a given document class will be more similar to each other, but documents that are related to different classes, then the distance increases as well, even though they are not like direct antonyms. I would say that is my intuition on how the model would behave in general.
Okay, thank you. And I have one more question, maybe more philosophical. I tried to build my intuition, because I think that maybe for antonyms, at least for a certain type of antonyms, it is actually a kind of necessary condition that their embeddings are similar to each other. I mean, if we are talking about antonyms, they should occur to some extent in the same context by definition.
Yeah, I think like the usefulness of this extension really depends on the problem that you are trying to solve. So, for example, I think this can be very helpful in stuff like sentiment analysis, or maybe even, I hope so, this is the goal that I have set, to explore the usefulness of this method in like financial predictions. So I think in this case, it might make sense. But if you look at some other tasks, I think in that case, you might be actually better with like considering or having similar embeddings for both, for antonyms and basically synonyms and so on. So yeah,
okay,
I agree.
Thank you. Thank you very much.
Thank you. And I have a few more very related comments to the last comment. The first is about this U. I have to assume that for practical reasons, this has to be be treated as a hyperparameter that you would tune just like any others, right?
Yes, yes.
So that we have to consider that for the task at hand, apart from also choosing how you define your label. So these two things add to the complexity or practicality of the approach, right?
Yes, I agree with that. Like, as you mentioned, the U is basically a hyperparameter that needs to be set by some method or, yeah.
In this case, was the how many days in advance you
Yes.
with the prediction. So maybe, yeah, you should clearly state those, but also maybe on the bright side of this, maybe you should also consider about the transfer learning. Like if you tune this and maybe you have some better word embeddings for some specific task, you don't have to really retrain and just use those embeddings for other similar tasks in the financial domain. In your case, even though you train them at a very specific document class. So maybe those are still better than the vanilla GenSim.
Yes, yes, I agree with this. Actually, one person pointed this idea to me just a few weeks ago when I was in in the Netherlands, and they had a similar comment on this. So yeah, I agree with this.
Okay.
Yeah.
So thanks.